So hello guys, this is Wasim Khan and I'm a mechatronics engineer and welcome to my channel Design and Simulation in Mechanical Engineering. Now guys, this is my third video of the press arm design and simulation in SolidWorks 2018. In the previous two videos I have shown you that how to design the press arm model and how to improve the design to make it more practical while we are manufacturing the mechanical press. And in the second video I have shown you the topology study of the press arm assembly, and as you can see I have shown you this model of the press arm plate that I have been taking into consideration for the topology study. Now I have improved this model to redesign it into a second SolidWorks file and make it refined for the machining process. Now you can see the edges are smooth, and also the mass of this material have been reduced to about 5.5 kg. Now in this lecture I will show you how to use this model, this part, and reuse it in the press arm assembly and do a static and fatigue analysis of the press arm assembly. Now let's see how I do the static analysis of the press arm by using the modified version of this plate arm assembly. So let's go to the part that I have been showing you in this video. So guys, this is the assembly of the press arm that has been modified to in this video. Now as you can see, the middle plate has been chosen, the one that I have been improved it in the topology study, and these two flanges are the same as they are used in the previous design of the static simulation of the original with the original arm plate. So we will see how this model behave when we carried out the static analysis of this design, and then we have to compare this the static analysis of this model with the previous one as we have performed in the first video of the press arm, and show you how the factor of safety and the stiffness of this material has been improved to a very good extent. Now to check the mass of the whole assembly, I will show you that sorry. Now as you can see, just a second, I have to change it to into kg. So as you can see, the mass of this whole assembly has been improved from 17.31 kg as I have shown you in the previous video to 13.47 kg. Now it has been improved to about 5 kg. So guys, there is another part that I have been added to this model is the bottom plate that I have been welded into this plate. Now this plate has been carrying the load, so I model a separate plate for this model, and as you can see that I split that part into two parts so that I have to apply some force and pressure to this plate, and we have to simulate this model for two different force types. One, we will apply a force to this edge, and the second, we apply the pressure on this face as we have done before in the previous video. So let's see how we do the static analysis, and I will show you the stepwise procedure of the boundary conditions that I have been applying. So as you can see that this is the part, and I have assigned the gray cast iron to all the parts. And now in the connections, as I have shown you earlier, that these connections are the bonds I applied to the joints of this assembly. So it's almost the same in this model also, in this study also. And now for most realistic behavior of this model, I also assign some non-penetration connections between this plate and the two flanges. Now I want to show you in detail that how I apply the no penetration contacts between the models. Now as you can see, the face of the plate and the face that has been attached to this plate has been applying the no penetration contact, and I also check the friction portion, because the friction between cast iron is approximately 0.15, so I put that value into the properties. So click OK, and now I have defined another contacts for other parts also, because this part is also in contact with this plate. So I apply a no penetration contact to this plate, because when a force is applied to a body, so it may not penetrate into this plate. So I applied the no penetration contact between these two bodies. So again I have put the pressure friction value as 0.15, and this is these are the no penetration contacts, while the bonded connection is between these two plates. Now as I model this plate as a single part, but I split it into two parts, the SolidWorks cannot behave as at a single part, because it has been split into two parts. The SolidWorks always behave consider this body as two parts. So I put a bonded connection between these two faces. So take care of this behavior, because SolidWorks cannot behave this part as a whole body. They are now two parts. So the whole boundary conditions are defined. Now in the fixed support, I have applied the fixed support to the holes, and now we go to the external loads. Now I applied a force of 5,000 pound in the upward direction on this edge, because as I have shown you in the first video that a force of approximately 5,000 pounds has been pressed by the mechanical press. So this force has been directing in the same direction as I have applied pressure in the previous video. Now there I put a pressure of 5,000 pounds and select the edges that I want to applied forces on. So, and also you have to select the plane to which these forces are perpendicular or parallel to. So this is the force that is acting on this face. Now as I have already done the simulation before in this for this design, now I want to show you the results of the simulation that I have done before. Now as you can see, the forces are quite low in this design. You can see in the previous video the one measure stresses was 100 megapascal, and now there you can see it is just 72.5 megapascal, and the displacement was a little higher in this case, but it does not depends too much on the displacement, or it does not uh, the displacement there are 0.389 mm and the maximum displacement occur in this body, the plate that we have modified in the topology study. Now if we go to the factor of safety, it has been improved to around 1.756. So a lot improvement has been done by modifying this part uh, to make it fit for machining, and also easy and also less costly. Now the force analysis has been done, and now we will check how this behavior this plate act like when a pressure load is applied on it. Now the second static study that I have been performed was for pressure. The whole thing is the same, only the pressure force there is different from the force that I have applied on this edge. So you have to apply the same pressure load on this face that I have been performed in the previous video. That is the first lecture that I have shown you. So nothing much doing in this static analysis, and you have to only evaluate the results. Now the stresses in this section is almost the same. As you can see, 69.66 megapascal, and in the first case the force when we applied the force on this body, it was about 72.5. So almost a 3.5 megapascal difference is uh, observed here, and the displacement is a little lower in this case. It is about 0.29 or 0.3, and in the first case, in the first static study, it was about 0.38 mm. Now when we look at the factor of safety, it is almost the same. It is 1.8, and in the first static study it is about 1.75, or it is almost in both case 1.8, close to 1.8. So as you can see that the static behavior for the pressure and the force load types are almost the same, and there is not much difference between these two force analysis. Now in the next section I will show you how to perform the fatigue analysis of this assembly. Now guys, we have performed the static analysis of both the loading times on the design, and we see that there is not much difference in the result section. So both of these loading times are equivalent to each other, and I have told you that the pressure force that I have applied have been calculated from the force that is given by, and the area of the section there, or the face that you have to apply the pressure loading. So you have seen the results, and now in the next video we will be performing the fatigue analysis of these models for the different loading types, and see also the result of the fatigue data that we will be generating in the next video. So guys, hope you could understand this video, and if you like my video, please subscribe and click the bell icon to see more notification of my videos. Please comment if you have any question in the comment section, and I will give you the answer. For now, thank you very much.